Hello everyone. In this session, we are going to solve a numerical based on zeolite method. So zeolite method we had seen in the previous session. So those who have not seen it can just go and check out my previous video. Let's have a look at the question. A zeolite bed exhausted by softening 4,000 liters of water sample requires 10 liters of 15% NaCl solution for regeneration. And we have to calculate the hardness of water sample. So first let's write down what all things are given. So first we are given here that it requires 15% of NaCl solution. Amount of water which was softened by zeolite is 4,000 liters and we require 10 liters of 15% NaCl for regeneration of the zeolite bed. So first let's convert this 15% of NaCl into the strength of NaCl. So 15% is 15 upon 100, 15 gram upon 100 ml. Now strength of NaCl is in gram per liter. So we have to convert this ml into liter. So we know 1 liter is equal to 1000 ml. So we need to add a 0 here in the denominator. If we add a 0 here in the denominator to make it 1000 ml, we need to add a 0 in the numerator also. So the strength of NaCl will be 150 gram per liter. So we have converted this 15% of NaCl into its strength, which is 150 gram per liter. Next, we know the volume of NaCl and we know the volume of water which was softened, and we have to find the hardness of water sample. So this numerical is solved in 3 steps. First step is we have to calculate the amount of NaCl required for regeneration in mg from its concentration. So we have the strength of NaCl, we have the volume of NaCl. We need to calculate the amount by using the strength and volume of NaCl. So amount of NaCl in milligram we want. It will be equal to the strength of NaCl into the liter of NaCl, which is the volume of NaCl, into 1000. So we will just substitute the values. The strength of NaCl which we have just calculated, it is 150 gram per liter, into volume of NaCl which is given in the question, it is 10 liters, into 1000. When you multiply this, you get the amount of NaCl in mg, which is 1.5 into 10 raised to 6 mg of NaCl. Now we have got the amount of NaCl in mg. The second step is to convert this amount of NaCl in mg into in terms of hardness, in the unit of hardness. So it is in mg, we have to convert it into mg of calcium carbonate equivalent. So 3, it is not up, it is at the bottom. So how we are going to do this? So we have seen how we can convert the amount of any salt into hardness, that is in terms of mg of calcium carbonate equivalent in the previous sessions. So the formula is amount of NaCl in terms of calcium carbonate equivalent would be equal to amount of NaCl in mg, which we have found in the step 1, into 50. 50 is the equivalent weight of calcium carbonate. Calcium carbonate's molecular weight is 100, its equivalent weight is 50, upon the equivalent weight of the salt. So NaCl, equivalent weight of NaCl is 58.5. You have to just add the weights of sodium and calcium. So you will get the amount as 58.5, because sodium it is 23, chloride, not calcium, sorry, sodium is 23, chloride is 35.5. So if you add, it is 58.5. So this formula we have used in calculating the hardness of water. So you can check those numericals. So the value is 1.28 into 10 raised to 6 mg of carbonate equivalent. So we have converted the amount of NaCl in terms of equivalence of calcium carbonate, and this is the amount. The third step is that we have to calculate the hardness. They have asked in the question, we have to calculate the hardness of water sample. So hardness of water sample would be equal to amount of NaCl in calcium carbonate equivalent upon volume of the water sample. So this is the amount of NaCl in calcium carbonate equivalent, and volume of water sample softened is 4000 liters. So as you put the values in the formula, you get the hardness of water, which is 320.51 ppm of calcium carbonate equivalent. So in this numerical, in zeolite numerical, either they ask you the hardness of water sample or they ask you the volume of water sample which is softened. So it is done in 3 steps. First step, if the strength of NaCl is given in percentage, you have to first convert it in gram per liter. Then you have to do the step 1, that is you have to calculate the amount of NaCl in mg from its strength and liter. In step 2, you have to convert that amount of NaCl which is in mg to equivalents of calcium carbonate. And in last step, you have to calculate either the hardness or the volume, whatever is asked. So here they had asked you hardness, so they have given the volume of water sample. Or else in some cases, they will ask you to calculate the volume of water sample and hardness would be mentioned. So you have to just switch the places. Instead of dividing the amount of NaCl in calcium carbonate equivalent by volume, you have to divide it by hardness if they have asked you to find the volume. So this is how the numerical is solved. There are some sample questions in the next slide which you can try by yourself in the same way. So in this question, you can see that the hardness of 50,000 liters of water sample was removed by passing it through a zeolite softener. So they have given the volume of water sample which was softened. Then they have given the softener required to NaCl solution. So this is the volume of NaCl which is given, containing 125 gram per liter of NaCl for regeneration. So this 125 gram per liter of NaCl, so they have directly given the strength of NaCl. Here you don't need to convert it, they have directly given it. If it is given in percentage, then you have to convert it in gram per liter of NaCl to find the strength. And here we have to calculate the hardness. So in this case, whatever the amount of NaCl which you will get in step 2 in terms of equivalence of calcium carbonate, you have to divide it by the volume of water sample given 50,000 to find the hardness. This is another question. So here again they have given that exhausted zeolite softener was regenerated by 150 liter of 18% NaCl. So this is the volume of NaCl. This is the percentage of NaCl which you have to convert it into its strength. And you have been asked to find the liters of hard water having hardness 300 ppm. So you have to find the volume of water sample and hardness is given. Similarly, this is question 4. So there are 3 questions which you can try and solve. If you have any doubts, you can simply put it in the comment section. Thank you.